The heat of the Sicilian summer pressed down on the island like a heavy hand in July 1943. Dust hung in the air, kicked up by trucks, boots, and the endless movement of soldiers preparing for the next assault. The invasion of Sicily had turned every field, every orchard, and every stone farmhouse into a battlefield. Overhead, the sky throbbed with the distant rumble of engines as Allied transports and fighters crossed the coastline in long, determined streams. Among them flew a formation of C-47 sky trains, each carrying paratroopers who would jump into the chaos below. One of those transports never made it back. Caught by German and Italian anti-aircraft fire on its return route, the Skytrain tried to limp south, its engines coughing, its wing roots smoking. The aircraft descended in a shallow arc over a grove of olive trees. The left engine sputtered a final time before seizing. The pilot, fighting the yoke with fading strength, managed to bring the aircraft down in a rough but controlled belly landing. Dust exploded around it as the wheels tore through the soil. The fuselage scraped across the dry ground until the plane came to a shuddering stop near a stone wall. The crew scrambled out and fled toward Allied lines, leaving behind a wounded but intact machine. Within hours, German patrols reached the crash site. At first glance, the Dakota, as the British called it, looked plain. It had no sleek lines like a Messerschmitt, no imposing silhouette like a Junkers bomber. It was simply a transport aircraft, utilitarian and unremarkable. But the Germans knew better than to ignore enemy technology. They quickly secured the area and summoned a team of Luftwaffe engineers from an airfield near Catania. When the engineers arrived, they approached the downed aircraft with the cautious excitement of men who lived to understand machines. One of them, a veteran inspector who had examined everything from captured Spitfires to Soviet Yak fighters, walked slowly around the fuselage, running his hand across the skin of the aircraft. He expected thin metal, perhaps dented by the landing. Instead, he felt something surprising. The surface was smooth, rigid, and far tougher than he anticipated. He tapped it with his knuckles. It rang with a firmness that did not match its weight. He motioned to another engineer. They tested the skin again. Light, strong, more than it should be. They exchanged glances. Something about this transport was different. The interior told another story. They stepped inside through the torn cargo door, expecting chaos. But the cabin was simple, almost Spartan. Cargo rails, bench seating, exposed ribs, straight lines everywhere. The engineers knelt, touched, measured, and recorded. They noticed how the floor panels lifted easily, how the bulkheads could be accessed without tools, and how the wiring ran cleanly along the fuselage with minimal complexity. There was nothing glamorous in the design, no polished fittings, no intricate mechanisms. Everything seemed built for one purpose: to work, and to keep working. Even in a crash landing, the cables had remained in place. The control pulleys spun freely. The fuel lines remained intact. The Germans found themselves murmuring in confusion. American machines were supposed to be crude copies of European engineering, or so propaganda often claimed. Yet this transport had survived a landing that would have torn apart many of their own designs. And it had done so with an almost stubborn simplicity. Outside, Wehrmacht soldiers gathered pieces of wreckage that had broken off during the skid. When they handed these fragments to the engineers, the surprise grew deeper. The aluminum alloy was lighter than expected. The rivet spacing was precise. The stress lines revealed careful load distribution. The lead engineer turned to his colleagues with a quiet statement: "This is no ordinary transport." The Germans began a more thorough inspection. They tested bends in the skin. They examined the wing root construction. They studied the reinforced floor beams designed to handle heavy cargo loads. They even checked the landing gear mounts, noting how clean and structurally efficient the design was. Everything about the aircraft suggested a philosophy they were not used to:
Not elegance, not speed, not German engineering complexity, but endurance. It was as if the aircraft had been built by people who expected it to fly in deserts, jungles, mountains, and storms. An aircraft meant for pilots who did not have perfect airfields, or perfect fuel, or perfect mechanics. A machine built to survive war not through sophistication, but through resilience. By late afternoon, as the Sicilian sun fell in long orange stripes across the wreckage, the lead engineer wrote the first sentence of what would become a famous report. "This airplane is built not for beauty or refinement. It is built to last forever." The men around him nodded. They understood that the aircraft before them was more than a transport. It was a philosophy in metal, a machine that survived because it refused to break. And in that moment, standing beside a broken but unbowed Dakota, the Germans began to realize why the Allies trusted this aircraft so deeply and why it had earned a reputation on every front line of the war as the machine that simply would not quit. The next morning, the Sicilian sun rose over the crash site, turning the olive trees gold and warming the metal of the downed Dakota until it glowed faintly in the light. The Luftwaffe engineers returned with proper tools, notebooks, calipers, and small testing kits. They were eager to understand why the aircraft had survived a landing that should have torn it apart. The lead engineer directed his team to begin with the outer skin. They removed a panel from the fuselage near the tail section where the impact had left only shallow dents. When they lifted it from the frame, they were immediately struck by its weight, or rather, the lack of weight. The panel was far lighter than expected for something that had protected the aircraft through a crash landing. The metal flexed slightly between their hands, springing back into shape with a resilience that made the engineers pause. They bent it again, still resisted, still returned. One of them scratched the surface with a small tool and noticed the outer layer was slightly different from the inner core, a protective cladding. A thin, pure aluminum surface bonded to a high-strength alloy beneath, an American version of Alclad. The Germans knew about layered alloys, but this one felt refined in a way that surprised them. Not delicate, not brittle, not something that required delicate maintenance. It was simply strong. Strong and light. The lead engineer marked his notes with growing interest. He knew that aluminum strength came at a cost. Most alloys used in Luftwaffe designs required meticulous care, protection from corrosion, or special treatments during manufacturing. This alloy, by contrast, looked as if it could be exposed to the sun, the sea, and the rain, then be wiped clean and used again without hesitation. They moved to the wing route, where the forces of landing had been greatest. When they inspected the structural ribs, they again found metal that defied expectations. The Germans were accustomed to intricate lattice frameworks or stressed skin methods that required high-precision machining. The Dakota used something simpler: straight spars, thick ribs, clean joins, efficient rivet lines spaced with mathematical precision yet executed with mass production in mind. There was nothing fragile here, no dependence on tight tolerances, no vulnerability to dust or grit. It was as if the Americans designed the aircraft to be repaired in the middle of nowhere by a man with nothing more than a hammer and determination. One engineer knelt beside the wing and scraped away paint to reach the bare metal. He tested it with a small magnet and smiled. Non-magnetic, just as expected, but the density reading he obtained made him frown in confusion. He tested again. Same result. The alloy was lighter than comparable German designs, yet could clearly absorb severe punishment. Another engineer performed a crude field bending test on a small strip removed from the damaged flap. He bent it sharply until his knuckles turned white. The strip creaked but held. It did not crack, it did not shear. It simply bowed, and then returned almost to its original shape. He looked up at his colleagues with disbelief. "This is not normal aluminum." The phrase passed around the group like a revelation. They tested rivet strength next. German aircraft often used flush rivets for aerodynamic cleanliness, a design choice that looked elegant but required more delicate maintenance. The Dakota used round head rivets that protruded slightly but distributed stress over a wider surface area. Stronger, simpler, faster to install, almost impossible to loosen under vibration. The Germans pulled several rivets out with a portable tool and examined the shank. Uniform, clean, overbuilt, reliable. Everything about the construction radiated the same idea: function over form. There was no elegance in appearance, but every piece served a purpose and served it well. The engineers then inspected the cargo floor. They expected light material suitable only for modest loads. Instead, they found reinforced beams capable of supporting heavy cargo, jeeps, fuel drums, and equipment that would overstress many German transports. The beams had survived the crash with minimal bending, protected by the intelligent arrangement of stress paths through the fuselage. And again, they saw it: simplicity, strength, durability. The aircraft had been built for punishment: battalions of paratroopers, rough landings, dirt airstrips, tropical humidity, winter ice. It was a machine expected to work everywhere without complaint. As they pieced together the structure, the Luftwaffe engineers began to understand the philosophical divide between German and American aircraft design. German designs often celebrated precision, high performance, and advanced engineering that pushed the limits of technology. The Dakota did not push any limits. It simply met every requirement of war with unwavering reliability. One of the engineers stepped back from the fuselage and shook his head slowly. Amerikaner bauen nicht schön. Sie bauen für die Ewigkeit. Americans do not build beautifully, they build for eternity. The others nodded. The truth was undeniable. The metallurgy alone proved it. The skin of the Dakota was a shield, not polished, not perfect, but incredibly difficult to break. And as they finished their analysis, the engineers realized why this modest-looking transport had become the backbone of Allied logistics. Its skin did not crack. Its frame did not twist. Its materials did not fail under stress. The Dakota survived because it was built from metal that refused to bend to war. It was the first secret the Germans uncovered, and they sensed more secrets waiting in the engines that rested silently under the Sicilian sun.
The Germans approached the engines of the downed Dakota with a mixture of curiosity and skepticism. In their minds, American engines were powerful but crude, designed for mass production rather than refined engineering. They expected the Pratt Whitney R-1830 Twin Wasp to confirm their assumptions. Instead, it dismantled them one piece at a time. The left engine had taken the worst of the crash. Its cowling was dented, its exhaust ring twisted, and several cylinders bore scorch marks from the flock damage that had crippled the aircraft. Yet when the engineers rotated the propeller by hand, the engine turned smoothly, almost politely, as if asking to be started again. The lead engineer raised an eyebrow. Engines with this level of impact usually locked up or fought against any movement. This one behaved as if it had landed gently, instead of belly-sliding through an olive grove. They began by removing the remaining cowling panels. The structure beneath was surprisingly clean. The cylinder heads were arranged in a neat radial pattern with generous spacing that allowed airflow to cool each one evenly. German engines often packed components tightly for aerodynamic efficiency. The American approach was different. They left room for mechanics to work. Bolts, plugs, wires, everything was visible, logical, and within reach. One engineer crouched beside a cylinder and ran his fingers over the cooling fins. Thick, evenly spaced, generous in number. He checked the ignition wires. Dual ignition,
redundant magnetos, a system designed so that if one half failed, the other half would carry on without hesitation. Not exotic, not delicate, but reliable in a way that made sense for a global war fought in deserts, jungles, and frozen islands. Another engineer examined the carburetor with great interest. German aircraft often used fuel injection systems that provided excellent performance but demanded precise calibration and high-grade fuel. The Dakota used a simple, sturdy carburetor that tolerated impurities, varied mixtures, and rough handling. It did not give perfect performance at all altitudes, but it refused to quit. It fed the engine consistently, forgiving errors, forgiving weather, forgiving conditions that no engineer could predict. As they worked, one engineer murmured a quiet comment. This motor was made for men who do not have perfect fuel. The others nodded. Next, they drained the oil. They expected burnt residue or metal fragments from the hard landing. Instead, the oil came out cleaner than anticipated, darkened by heat but not contaminated by shattered parts. They opened the filter. No flakes, no shavings, no warning signs. The engine had taken damage, but it had not failed. They studied the valves, the rocker arms, the pushrod tubes. Everything was simple, durable, and arranged for easy maintenance. A mechanic could change plugs in minutes. A field crew could swap a cylinder bank without special tools. And the Germans found themselves confronting a startling truth. The Americans had not built their engines for maximum output. They had built them for unstoppable endurance. One engineer laughed under his breath, not mockingly, but in disbelief. "We make engines for precision," he said. "They make engines for war." They decided to attempt a full rotation test. Several engineers gripped the blades of the propeller and pulled. The engine spun freely. No grinding, no hesitation. The pistons compressed with steady rhythm. For a moment, the team simply watched, stunned. This engine had survived flak, a crippled flight, a crash landing, and hours in the Sicilian heat. Yet it behaved like a machine fresh from the factory. One of the younger engineers checked the ignition wires manually. They sparked, strongly, consistently. He looked back at his colleagues with an astonished grin. "She wants to start." The lead engineer hesitated. It was risky. Fuel lines were damaged, the exhaust ring was bent, oil levels were low. But the moment felt significant. He nodded. "Prepare it." They connected a small auxiliary tank and rigged a temporary ignition switch. The propeller was positioned. The lead engineer signaled the crew. "Contact." They pulled. The engine coughed once, coughed again, then it roared to life, not weakly, not irregularly, but with a full-throated growl that echoed across the olive grove. The Germans stepped back in shock as the Twin Wasp shook away the dust of battle and settled into a steady, confident idle. The propeller blurred into a silver circle. The cylinders thumped in the smooth radial cadence that Allied crews had trusted over every ocean and every battlefield. They stared, speechless. An engine that should have been silent was alive. An engine that should have been ruined was strong. When they finally shut it down, the lead engineer wrote a single line in his notebook. "This engine refuses to die." The team compared the Twin Wasp to their own designs. German engines often sought efficiency, power, and cutting-edge performance. They demanded expert maintenance. They pushed the limits of metallurgy and aerodynamics. But the American engine pursued something else entirely. Margin, forgiveness, endurance. It accepted poor fuel, rough handling, and battlefield conditions. It sacrificed perfection in exchange for reliability that bordered on myth. The Germans realized that the C-47 could keep flying, even when wounded, because its beating heart never stopped. The Twin Wasp was not the most advanced engine in the war. It was simply the one that kept running longest. And as the engineers packed their tools and prepared their formal report, they understood something deeper. The engine mirrored the aircraft. Both were built not to impress, but to endure. Not to push boundaries, but to survive them. Not to dazzle with innovation, but to deliver with consistency. In a war where complexity was failing faster than armies could repair it, the Americans had chosen a different path. And the Germans, standing beside a battered but still breathing Dakota, began to grasp why the Allies could move men and supplies across continents with a rhythm that seemed unstoppable. The secret was not brilliance. The secret was reliability.
By the time the Germans moved from the engines to the flight controls of the downed Dakota, they already sensed a pattern. Everything they had examined so far pointed toward a philosophy that was almost alien to them. Not refinement, but resilience. Not elegance, but clarity. Now, as they opened inspection panels along the wings and fuselage, that philosophy revealed itself with simplicity so stark it left them standing in silence. The first thing they noticed was the control cables. No complicated hydraulic servos, no delicate gearboxes, no electric boosters hidden behind access doors. Just thick, braided steel cables running through pulleys the size of a man's palm. Each pulley was held in place with rugged brackets, overbuilt and reinforced, as if the designers assumed the aircraft would be abused on rough fields or battered by freezing winds. One engineer tugged on a cable. It moved with a smoothness that surprised him. Another traced the cable run along the fuselage and nodded with appreciation. Straight, clean, minimal deviation. A design that reduced friction, reduced wear, reduced failure points. He whispered almost to himself. You could repair this in the dark. They tested a pulley. It spun freely. When they removed it, they found a large bearing housing that required little more than grease and a basic wrench. No precision tools, no specialized parts, replaceable anywhere in the world. One engineer laughed softly. Ein Kind kann es reparieren. A child could repair it. To German engineers, accustomed to aircraft like the Ju-52 and He-111, the Dakota's simplicity was almost shocking. Their machines used more complex systems, balancing aerodynamic performance with mechanical sophistication. But this American aircraft seemed designed from the first blueprint with one singular purpose: keep flying, no matter the climate, the airfield, or the skill level of the crew. Next, they inspected the control column linkages. Again, nothing fancy. Push rods that were thick, direct, and almost impossible to jam. Hinges that were not sleek but were brutally strong. Clevis pins so large they would have looked at home on a tank rather than a transport aircraft. They examined the elevator system. The cables ran through an elegantly simple arrangement of pulleys whose alignment was nearly perfect, not because of fine craftsmanship alone, but because the design itself tolerated rough handling and imperfect conditions. Even after the belly landing, the elevator linkages had remained intact. A few pulleys were scratched, one cable strand had frayed, but the system as a whole was still functional. One engineer behind the tail section stopped and stared at the trim wheel mechanism. He turned it slowly. It moved with satisfying resistance, lifting and lowering the trim tab with a precision he could feel through his fingertips. The mechanism was exposed, easy to inspect, easy to lubricate, easy to repair. No hidden compartments, no delicate gearing. He wrote in his notebook,
This airplane is designed for men who have never seen a proper workshop. Then came the aileron controls. Here again, the Dakota revealed its genius. Instead of multiple complex linkages, a single clean cable system ran through reinforced guide points. The cables were tensioned in a way that allowed small damage to be tolerated without immediate failure. A single frayed strand did not doom the aircraft. A pulley jam could be fixed with improvised tools. The Germans found themselves comparing it to the fighters and bombers they maintained daily. Their machines excelled at performance, but required careful calibration. The Dakota seemed almost proud of requiring none. The lead engineer instructed the team to check for redundancy. The Americans had installed dual cable paths in critical areas, ensuring that if one system was shot away, the pilot still had partial control. The engineers stared at one another. They knew the value of such redundancy. They also knew how rarely such features were implemented in German designs under wartime pressure. They moved next to the cockpit. The control yoke was thick, almost ugly by German standards, with grips that seemed designed for pilots wearing gloves caked with dust, oil, or frost. The throttle quadrant was equally robust, its levers large and forgiving. Nothing required delicate handling, nothing invited mechanical weakness. A young engineer sat in the pilot's seat and looked at the instrument panel. Simple gauges, clear markings, no excess, no maze of switches. The kind of cockpit any pilot could learn fast and rely upon even when shaken, wounded, or exhausted. He said quietly, "They build for the farm boy. We build for the engineer." The others understood. The Americans design aircraft for mass mobilization, for pilots with limited experience, for mechanics working on mud, snow, or sand, for armies that moved across continents and needed machines that could adapt to whatever environment they found. The control surfaces of the Dakota could be removed and replaced in hours. The cables could be spliced with simple clamps. The pulleys could be changed with a screwdriver. A squad of infantry without formal training could keep the aircraft operational long enough for proper mechanics to arrive. Finally, the engineers tested one more element. They climbed onto the wing, reached into the aileron inspection panel, and applied pressure to the cables while another man moved the yoke inside the cockpit. The surfaces responded instantly, smoothly, without hesitation. The lead engineer closed his notebook with a soft but decisive motion. "This is not brilliance," he said. "This is wisdom." The Dakota's control systems were not revolutionary. They were rational, purposeful, resilient. And that resilience explains something the Germans already suspected. Why Allied supply lines never seemed to break. Why Dakota transports crossed oceans and mountains with confidence. Why paratroopers trusted the aircraft that carried them into darkness. The Dakota did not need complexity. It needed to work. Always. And as the Germans stepped back from the aircraft, dust swirling around its scarred fuselage, they understood that they had uncovered the third secret of its success. The Dakota could be kept alive by anyone with 2 hands and determination. In a war of attrition, that made it nearly unstoppable.
By the time the Germans completed their examination of the downed Dakota, the sun was sinking low over the Sicilian hills, casting long shadows across the olive grove where the aircraft had landed. The Luftwaffe engineers gathered beside the battered transport, notebooks heavy with sketches, diagrams, measurements, and observations. They had opened every panel, tested every component, and reviewed every part of the machine from its nose to its tail. What began as a simple inspection had become a revelation. They now understood that the Dakota was not an accident of mass production or a lucky design. It was deliberate. Every inch of it, every screw, cable, alloy, and hinge had been crafted with one goal above all else: to keep flying.
The lead engineer stood at the wing root, staring at the aircraft in silence before addressing his team. "We build machines to perform," he said. "They build machines to endure." It was not criticism, it was admiration. They began writing their formal report, a document that would circulate through intelligence channels and technical offices within the Luftwaffe. The opening line alone said everything. "This aircraft represents a philosophy we have underestimated." They detailed the alloy skin that refused to crack, the structure that absorbed punishment, the engines that started even after a crash, the controls that could be repaired in the field by soldiers with no specialized training. The report drew comparisons between the Dakota and German transports. The Ju-52 was rugged, yes, but old, heavy, slow, built in another era. The He-111 conversions were fragile and vulnerable. The Ma-323 Gigant was powerful, but required entire ground crews and armored columns to support it. Against all of them, the Dakota stood apart. It could land on dirt, sand, ice, or grass. It could be repaired with the simplest tools. It could haul cargo far beyond what its delicate appearance suggested. And most of all, it simply refused to stop working. One section of the report described the engines. "Even after damage and poor conditions, both power plants show an extraordinary willingness to operate. This is not high technology. This is good technology." Another section addressed field maintenance. "A single Jeep can service this aircraft. A single airman can perform half its upkeep. Complex repair shops are unnecessary." And perhaps the most revealing sentence of all came near the end. "If we possessed an aircraft of this kind, our logistical fortunes in this war might be very different." The engineers did not exaggerate. They knew that the war in North Africa, the retreat from Stalingrad, the supply struggles in Italy, every one of those operations had suffered because German logistics depended on machines that were too fragile, too complex, or too resource-intensive. The Dakota represented the opposite approach. It was the Allied backbone, the silent strength behind every invasion, every airborne assault, every front line in need of food, ammunition, fuel, or evacuation. When the engineers finished their report, they stood quietly around the wrecked aircraft. The olive grove was still, the only sound the whisper of the wind brushing against the torn fabric of the control surfaces. One of the younger engineers broke the silence. "This machine will fly again if we let it." The others looked at him, then at the aircraft. He was not wrong. With a few replacement parts, fresh oil, and a small fuel truck, the Dakota would likely be coaxed back into the sky. Even in death, it seemed unwilling to accept defeat. But the wreck would never fly again. Orders were orders. The engineers collected their tools and prepared to depart. Intelligence officers would arrive soon to evaluate whether anything should be salvaged or destroyed. Before leaving, the lead engineer placed his hand on the fuselage one last time. He was not thinking about alloys or cables or engines. He was thinking about something far more human. The men who had flown this machine, the men who had trusted it with their lives, the men who jumped from its doors into darkness. He understood now why they trusted it. He whispered almost to himself, "The Americans have built not a machine, but a companion." The Dakota had proven itself across the globe, over the Burmese jungle, across the deserts of Africa, through the storms of the North Atlantic, over the frozen Aleutian Islands, and now, even in its broken state in Sicily, it taught its enemies something they had never realized. Reliability wins wars. Not speed, not complexity, not beauty. Just the relentless, stubborn refusal of a machine to break down even when everything around it is falling apart. As the Germans walked away and the evening air cooled over the wreck, the Dakota remained where it fell, silent, weathered, but still whole. It was a testament not to brilliance, but to purpose, not to innovation, but to endurance. And as history would later prove, the aircraft they studied that day would not die in Sicily, nor would its legacy. Long after the war ended, Dakotas flew on. They carried food to Berlin, mail to Alaska, medicine across Africa, and passengers across South America. Some flew for 50 years, some still fly today. The Germans had been right. The Dakota was not built to impress, it was built to last forever.